What's up, Nightwalkers? I've got a great video for you guys today. I'm going over the TNVC BNVG-M, aka the Artemis. Okay, first things first, in full disclosure, I work at TNVC. However, this YouTube channel has nothing to do with my employment at TNVC. I've been doing this YouTube channel for a while now. Just got to make that clear. Now with the Artemis here, and technically this thing is called the BNVG-M, and that stands for Binocular Night Vision Goggle, Modular. It's most commonly known as the Artemis, and that's how I'm going to call it. In this video, it's a lot easier than saying BNVG-M. Now, the Artemis has been in development for a while now. In fact, I first caught wind of this thing before I came to work at TNVC, and I had such a strong interest to buy this goggle that I was harassing the guys at TNVC about this thing, you know, nonstop almost, or at least every other month or something. Just, hey, do you guys have any updates on this Artemis? Obviously, coming to work at TNVC, you know, I get access to products that we have and get a chance to use them and stuff like that. What's unique about the Artemis is that this is a true TNVC designed and developed night vision goggle. This is only available in the Cerakoted FDE finish. In my opinion, every goggle should come in FDE. That's just my personal opinion. Main reason being is that this FDE finish has a better IR profile compared to black, and that's my primary reason. Although FDE just looks, you know, kick-ass. If you don't like FDE, the Aquarium has wraps available for the Artemis. You just pick whatever one you want. You know, multicam, woodland, multicam black, whatever it is. You can slap them on the Artemis to change the color if you don't like FDE. Now, another thing to point out is that the Artemis is only available with L3 Harris unfilmed white phosphor tubes at this time. Now, the bridge is made out of aluminum and the monocular pods are made out of Delrin. Both of those materials are super tough. I would have no concerns whatsoever to this thing having any potential breakage issues. I mean, if you were to break one of these systems, you probably got hurt really bad, or you didn't have it landed and you dropped it off of a really high height or something like that. And even then, the odds are you'd probably damage the lenses before you would damage the pods or the bridge. Even during the most extreme use, I'd have no concerns whatsoever for the bridge or the monocular pods having any kind of an issue. The Artemis is a modular system, and that's what the BNVG-M signifies, -M meaning modular. And what that modularity is referring to is the power supply or the interface on the goggle itself. And so here's a picture of the BNVS version, and that's basically going to give you a dovetail interface on top, and then a battery pack compartment or a battery compartment in the center here for a single CR123A, as well as on the BNVS version, you're going to have a power button here in the back to turn the goggle on and off, as well as a remote battery pack port on the back. It's going to be a Fisher port to go to, you know, cold weather battery packs by L3 Harris. We do have an adapter cable that's a TNVC product that will allow you to go from the Fisher connector to a LEMO connector, so you can run like an Anvis battery pack, AB night vision low profile battery pack, you know, that type of a thing. Swapping the power supplies is really easy. You got these 4 screws right here. You just take those out, and then you can basically remove this plate up here on the top, and that's how you swap out the power supplies. Here's a picture down here to kind of show you what that looks like. Now, when you order the Artemis, you're going to have to select it in one configuration or the other. So BNVS or ball detent, you know, BNVS or ANVS is going to be your main selection. However, you can purchase, you know, the other adapter at the same time or later on, depending on how you want to do it. You know, for the overall majority of people, even though I'm a huge fan of these ball detent systems, I do recommend that the BNVS system or the BNVS configuration is really what I recommend for most people. When it comes to these ball detent systems, I mean, you pretty much either know if you like them or you don't. This is a fixed bridge goggle. If you're not familiar with what that means, it basically means that these pods are fixed in place, that they don't, you know, swivel out of the way or move off of the bridge. Now, they do move left and right for your eye spacing, and that's done with these screws over here on both sides of the bridge. By adjusting these screws left to right and moving the pods left to right, you can get both eyepieces centered for both your eyes for the best image possible. There are some pros and cons to fixed bridge goggles over articulating. You know, articulating goggles would be something like the DTNVS or the PVS31. There's pros and cons to all of them. Many people like myself actually prefer a fixed bridge goggle over an articulating goggle, and the reason for that is that you always have a very consistent and super repeatable eye spacing. You know, these pods, because they don't move and they're fixed in place, once you get them adjusted for your eye spacing, it's going to stay exactly where it's supposed to be. And then when you flip the goggle up and you flip it back down, it's going to go exactly where it's supposed to be, so you get the best image possible. Another advantage that fixed bridge goggles have over articulating goggles is whenever you're using something like this clip-on thermal imager, which attaches to the night vision monocular pod. If you're not familiar with what these things are, I do have some videos. You can look back and see the Cody or the E-Cody. But basically, this is the thermal imager. It takes in the image right here through the front lens, and it projects the thermal image into the night vision device. With these fixed bridge goggles, since these pods don't articulate, they don't move, they stay fixed in place. Once you set your IPD spacing, they're not going to change. And so gravity can't take effect here and change the position of it. So when you flip the goggle up and you flip it back down, everything's going to stay exactly where it's supposed to be at. Whereas with an articulating goggle, because it's on a hinge, you have the possibility, it's pretty common actually, where your monocular pod's going to change position, in relation to your eye spacing, just due to the weight of this thing attached to the end of it. The only negative, in my opinion, when it comes to a fixed bridge goggle is the lack of ability to, articulate the pods up towards your eyebrows to get them out of the way versus having to flip the goggle up all the time, like is typically the case when it comes to a fixed bridge goggle. But now there's a trick. Isn't a new trick. It's not my trick by any means, but there is a trick to run fixed bridge goggles to where you don't always have to flip them up on your helmet. I'm just going to show it to you guys real quick with this Anvis configuration goggle. So the way you do that is simply, now you have to have it extended far enough away from the helmet so it clears the brim, okay? And myself, I find it better the further out I go. So for example, you move it out here, and then on the helmet mount, you're gonna raise this up as high as you can sometimes. It may not always be at the maximum height, but you basically wanna get them up towards the top of the helmet. And now it's kind of hard to see it or kind of gauge it because there's no head inside the helmet. But in this configuration, you kind of see the goggles look like they're pointing straight up. But right now, when I run it this way, I can look right underneath these goggles, no problem. And then the further away they are, I'm not getting as much light down into my face, and so it's perfectly manageable. I can run these like this and look underneath the goggles without having to flip them up. And if I need more space, I just kind of push up on the goggles, which then tilts my helmet up, and now I can see underneath them even better. And then if I have to go back under nods, all I got to do is tilt my head back down, and now I'm looking straight through the tubes. And so it's just a great little trick with fixed bridge goggles. You can do the same thing with the BNVS configuration, but I do find the Anvis profile is a little bit better for doing that. My personal preference between the two different power supplies or interfaces is the ball detent Anvis configuration. And so I'll just give you a quick visual representation of why that is, without hopefully not going into too much detail here to bore you guys. But so now in this ball detent interface, you see these two strips right here. This is how power is supplied to the goggle through this interface. There's no onboard battery on the Anvis configuration. And so just a quick visual, here's the helmet mount I'm using. This is a Wilcox GSGM. It gets power through a battery pack as this cable is basically bringing it into the goggle. It does have an onboard capability to run a CR123A. You can switch between it right here with the switch, protective cover on it. So anyways, you see the two contacts there on the sides, and now you got these two spring-loaded contacts inside the helmet mount. They're on both sides of the helmet mount, and these engage with these strips right here. And so let me just kind of show you a quick visual. So now, see how the strip is exposed? Now the strip's exposed. It's not making contact here on this ball in here, which is how it's power supplied to the goggle. You flip it down. Now it's engaged. Now the goggle's getting power. You flip it back up, disengage. That means the goggle's turned off. And so that's my personal preference for running these things. Is I like the ability to where the goggle, it turns off automatically, dead nuts reliable every time you flip it up. When I flip it down, it turns back on automatically. I'm not manipulating the power button. When I take it off of the helmet mount, so let's say I'm done for the night, I pop it out. There's no concern. There's no worry that I'm going to accidentally leave these turned on. I don't have to take a battery out of it. It's just my personal preference in terms of how to run a goggle. Some guys don't like these ball detent interfaces, and that's primarily because this mount by design, it's an aviation mount. It's designed for pilots to where when they eject out of the aircraft or if they get in a wreck, this mount can easily, just like you saw how I popped it in and out of here pretty easily. It's by design meant to be a breakaway goggle, so it'll come off the helmet mount. Some guys on the ground, they don't like that. They don't want to have a breakaway feature on their goggles, and so this wouldn't be the ideal, device with this interface for that type of of a request if you don't want a breakaway feature. Now, on even on the BNVS version now, if that's a concern where you want to have the breakaway, but you don't want to have the ball detent, it's an easy deal. All you got to do is get a breakaway mount like this Wilcox G24, and then you can have that same type of capability. You just have to remember to engage it and disengage it if you want to have that function or you do not want to have that function. Now, when it comes to why somebody would want the breakaway feature or not want it, I'll just kind of give you my take on it. I'm a huge advocate of breakaway systems. That's another reason why I like the ball detent. You know, it does power the way I want it, off and on automatically, as well as it's by design meant to be a breakaway system. The reason that's important, in my opinion, really depends on your use case. You know, for myself personally, you know, I'm walking on uneven terrain a lot of times on my property. I drive side-by-sides. Sometimes on ATVs, things like that. And for me, if I get into a wreck or if I face plant, something like that, I want the goggle to be able to break away. Not only is that going to help minimize any risk of neck injury to myself, but it's going to minimize any damage to the goggle. And that's because by the actual device popping out of the helmet mount, you know, all that energy, let's say if you face plant and you run these things into some ground, if it pops out of the mount, you're going to have very minimal likelihood that you're going to damage the goggle. Whereas if they're fixed in place, I mean, you're pretty much taking all that energy right into the goggle itself. You know, plus you may injure your neck, and that's not a good thing. Now, something to point out is if you are going to run a breakaway feature, you absolutely want to have these things lanyarded or attached to the helmet by some way. You know, whether it's a Kinetic Consulting nerd, it's a DIY paracord job, whatever, you want some way to attach this thing to your helmet so that way, you know, you're not going to lose them. So for example, you face plant, they end up rolling down a mountain, something like that. You get in a wreck on your ATV and they go flying. Now you got to go searching for them, that kind of thing. You can minimize that by having these attached to your helmet. And I'm going to show you my preferred way of doing that with these goggles. What you're looking at right here is the OpsCore modular bungee shroud. Now this shroud is only compatible with certain helmets, and so for example, this helmet I have right here is an OpsCore Fast Carbon helmet. It does allow for you to replace the shroud on the front. Newer OpsCore helmets like the Fast SF Carbon, Fast SF Ballistic, and some other models, they're going to come standard with the ANVS shroud. However, if you want to use this shroud, you just have to have the ability to remove your shroud in order to put it on. So this is only going to apply to helmets that are compatible with the ANVS shroud. So anyways, going into the ANVS shroud, if you look here, let me just zoom in on it real quick. You can see you've got these bungees that are integrated into the shroud itself. And the location of them, as you can see, they come down perfect and they just line up great with the Artemis's lanyard locations, or the bungee locations here on the bridge. As you can see, they're a nice open design. You don't need split rings to use this setup, as well as these bungees have a mini carabiner that are gated. So so unlike, you know, traditional bungee hooks that are open on the end, those can slip off of a bridge like that. Whereas this gated carabiner, you know, it can't come off. This is the ideal way, in my opinion, to run this thing if you can. If you can't, because you don't have a helmet that has the ability to take this ANVS shroud, then I would recommend looking at the Kinetic Consulting Nerd. That's a great way to run bungees down, attach them to the goggle. It's going to pull tension on the goggles as well as giving the ability to where if they detach, it's going to help them stay on the helmet. And in fact, you know, when it comes to using the BNVS version with the G24 mount, this is how the device is released off of the interface. And when you got bungees pulling tension on it, even if you accidentally hit the button, the bungees are going to pull the device back into the mount. And so the likelihood of them accidentally coming out by just accidental release of the button, it's just not going to happen if you have enough bungee tension on it. But it will do the job with the Nerd and other retention devices like that of maintaining the device being attached to your helmet versus losing it down a hill or the side of a mountain or something like that. Another reason that I recommend the ANVS shroud, especially if you're going to run it with the Anvis configuration, is because of this interface. And so let me show you the interface real quick. Now, the way these GSG-Ms are released, DPAMs as well, the way they're released off of this thing is you just basically move this lever here to basically, you know, take tension off of it, and then it's going to pop right off of the helmet mount. It just slides right off of it like this. And so what you're left with is this interface. And now this is a separate accessory to the ANVS. It's not very expensive. And the way this thing works is so the standard way this comes is you have a different interface that slides into the shroud. That's going to accept stuff like the G24. But now you just remove 2 screws, you slide out the standard interface, you take your Wilcox GSGM interface, slide it in, put your screws back in here, and now you have this interface. And then the way that works is your GSGM has this little notch right here, and that's going to slide in here and lock it in place. And so that's the best way to run it. The profile, because different helmets, they have different profiles to them. So for example, you've got like an ACH profile, and then you have a fast profile. And the profile refers to the angle of the slope of the helmet right here. And so the ANVS design with this Wilcox GSGM interface, it's going to position this thing in the exact position that you want it to be at. And the reason that's important, and I'll just show you here real quick. Let me put this thing back in here. Lock it back in. And so the reason that's important is the way adjustments are made with an Anvis system. Let me bring this back down. So the way adjustments are made is on the goggle itself, you've got all your adjustments are done except for your vertical adjustment on the goggle. So for example, right here, you've got your tilt adjustment on the Artemis is done with this wheel right here underneath the plate. That's how you adjust for the tilt of the goggle into the mount. So that's how you adjust for it right there. On the front here, this is how you adjust your fore and aft adjustment on the device itself in relation to the helmet mount and then the helmet. And so because that's your only means of adjustment for tilt and stuff like that, it gives you plenty of tilt adjustment. However, if your helmet angle is not correct right here, you're just going to be limited to how much you can tilt it. So having the correct profile right here is critical to getting the best view through an Anvis style goggle. Another thing with these ball detent goggles is when you stow them up on the helmet, it's way lower than it would be if it was a dovetail configuration. So it's kind of hard to kind of show you. I don't have the other one to show you back to back, but trust me, this is much lower. It's pretty much the same height as the helmet for the most part. And that's because of this profile right here. The way this hinge point is inside the ball detent mount, you can see where this bridge is in relation to it. It's much shorter than where it would be at with the dovetail configuration. It just keeps it much shorter. That's another reason why I like these ball detent goggles. All right, so going back into the Artemis, this button you see right here, this is for the onboard IR illuminator. Like I said, there's no power button on the Anvis configuration. The only power button is going to be on the BNVS, and it's going to be located back here. So this is your onboard IR illuminator. There's your IR illuminator output right there. This illuminator is actually really great, man. It works fantastic. I'm a huge fan of it. Low power. It's a fairly low power illuminator, but it's extremely usable. I'd say it's good for out to 25 yards or so, something like that. You get a really nice wide flood out of it. The reason I like to have a good, low power illuminator like that is like on my property where I'm at, I've got snakes, and during snake season, I obviously want to make sure I'm not going to run into one of those things on one of my walkways or if I'm hiking through the property. And so having a means to have a low power IR illuminator source, especially on those darker nights, for me, it's a critical requirement. For other people, you could use this thing as well for signaling purposes. Unlike some goggles, for example, the PVS 31s, BNVD 1531s, you have to double tap it, in quick succession, but it's not a fast process, in terms of turning on the IR illuminator. It does have a slight delay to it, whereas this thing's instantaneous. And so for what I'm getting at is for signaling purposes. So for example, if I wanted to signal somebody else using this IR illuminator, I could do it very easily just with these little presses right here on it, versus having to double tap a button to get it to come on. And for a goggle like that, signaling is definitely doable. You just have to cover up the IR illuminator with your finger and kind of do it that way. And so it's useful for that reason as well. But for me personally, using the onboard illuminator through my battery pack, I've got tons of power. I don't have to worry about running down a battery like on a Princeton Tech switch, for example. You got that little coin CR 2032 battery. It's just a pain in the ass changing those out, as well as, I just hate running down batteries on helmet lights if I don't have to. I like to kind of keep those as like mission critical type things for, for illumination if I really need it. If I just need low power IR to see a walkway, a goggle like this that has a good one, I'd just rather run my batteries off my battery pack versus using a helmet light. To wrap up the video, the Artemis is an awesome goggle, and I'm not just saying that, guys. I truly mean that. I've been waiting on this thing for a long time. Now that it's available, this is my go-to rig. I love this thing. And so the main reason why is, like I said, in the ball detent configuration, this is the best thing out there for that type of capability. And if you're going to run a BNVS, which is the dovetail, and not the ball detent, it's also, my recommended goggle as well. The RNVG is a great goggle, but it's got some downsides to it, namely being you got the post that comes up here that has your Illuminator on it, and it's got your battery pack, port on the side of it. Sometimes the location of that can cause compatibility problems with different helmet mounts out there. Not G24s, but maybe some of the Rotos mounts and other brands, as well as the battery pack cable coming out from this location right here. It's definitely more of a snag hazard. Whereas on the BNVS Artemis, you got the power button back here, which is a great location as well. And then the battery pack cable is going to come out on the back here, which runs up your helmet. It's really streamlined. It's just a better way to do it, in my opinion. As well as I like having the Illuminator location here in the center, which is where they should all be on goggles. In my opinion. I mean, when it's in flood, you don't get a huge difference with it, but I just like it being in the middle and not someplace else. So anyways, I hope you guys enjoyed the video. If you have any questions, just hit me up in the comments section, or you can get a hold of me through TNVC as well. All right, thanks for watching.